Hello everybody, welcome to my talk on Transformers, the all-in-one tool for natural language processing. This is me, Julio Martínez. You can find me on internet with the nickname Leopic. So let's start. Natural language is actually human language, so the idea behind natural language processing is to help computers understand humans. So the interaction between computers and humans become more fluid somehow, but human language is really complex. So how can we approach this problem? Actually splitting into tasks. This is a list of the most common natural language processing tasks, and let's see some of them. For instance, information retrieval is what you do usually when you visit Google. Given a keyword, you get documents that are relevant to that keyword. Or question answering, when you ask something and you get the exact answer. Or language translation, etc. So in order to work with all these tasks, you need to represent the language inside the computer with numbers. You could start translating characters into numbers, which make no sense because characters have no real meaning by themselves unless you are Chinese. So usually you are going to represent words or even sentences into numbers. If you study natural language processing, the bag of words technique is one of the techniques you are going to learn really soon. This is quite easy because one word represents one number. So you get a dictionary of all the documents that you are working with, and you assign a number to each one of the words that happen there. The good thing is this technique is easy to understand. The problem is that it doesn't really work in all those tasks. Actually, it's only useful for text retrieval or perhaps topic modeling when the words are really split well between the topics. And also you need a lot of tricks like stemming to remove plurals or do some statistics like the tire frequency, inverse document frequency. An improvement of this is the word embedding techniques, in which one word becomes a vector of numbers, usually from 100 to 300 dimensions numbers. These vectors can be created with different methods, but Google publishing 7 years ago a toolkit called Word2Vec, in which using a neural network, you get those vectors with a quite easy technique, which basically is you explore the meaning of a word related to the surrounding words. The good thing is that with vectors you can do operations and get directions. For instance, in the bottom left you see the classic from male word to female word, or even you can do crazy things like get random words like square, round, meat and vegetable, as you see in the right side, and create a hyperplane and project other words, and most of them make sense. And this is one of the good things of word embeddings. It captures more or less meanings, and as it is unsupervised learning, you don't need to label things. But also you use already trained embeddings as the start of your neural network, as the shallow layers of the neural network. And this can be a problem because each time you change the task, you have to retrain totally your new neural network. And also the problem with word embeddings is that they fail to capture high-level information. For instance, wine red, which is a color, and red wine, which is a drink, could end up getting the same word embedding. Or a word like bank, which has several meanings, get the somehow average of all those meanings. So we need a better system. We need a better system to capture meaning. Meet transformers. Transformers are not these cars that become robots, but transformers are this. This is a big block, and 3 years ago appeared in a paper called Attention is All You Need. Let's see the idea behind this. The main idea is that you have a multi-head attention, and you get as input not only the words, but also the position, the relative position between the words. So this multi-head is actually several layers of attention heads. Attention heads help to relate one word to other words in a sentence, in a way that you get in one head, for instance, the relation between the plural in a word here should imply the plural in another word, or more high-level information. At the end, transformers capture better meaning and capture in a way that you can use complete sentence, even paragraphs. And the other good thing is that as this is a big block, you usually get this block with already trained the weights of the neural network. So you only need to add a few more layers to adapt this big block to the tasks you are working with. Of course, this is more complex, but I think the trade-off is worth it. Let's speak about transformers in Python, because this is a Python conference, right? So you can start building your own transformer with TensorFlow or PyTorch, or you can use Hugging Face package. This is a library that comes with already trained models like BERT by Google, or GPT-2, or others. And the good thing is that all these models come with TensorFlow and PyTorch biddings. So you don't need to change your favorite deep learning library. But for me, the best of this library is that it comes with a high-level interface called pipelines, in which you can use transformer without the need of understand what's behind. For instance, here you have an example. You just load a pipeline with a question answering task, and you give some context, like this Saturday we have an online event, blah 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 blah, and you ask a question, when does the event happens? And the result is quite good, because the answer is Saturday, with a 77% of score. Of course, this is an easy example, and usually you are going to give a big chunk of text as context. You can try things like another task, fill in mask, in which, for instance, here the capital of Catalonia is Barcelona, with a 57% of score. And this is already trained knowledge. And most of the time, as I said before, you are going to use a big chunk of text. Otherwise, you can get kind of funny things like, my husband is dead, unemployed, gay. I invite you to use Hugging Face pipelines, because they are, as you see, really easy to use and comes with a lot of different tasks, like translation, summarization, sentiment analysis, text generation. They come in English. You can use models with multilingual training, or even in Spanish. And that's all. Thank you for listening, and thank you to the organizers for making this event. Questions?